Okay, thank you. Yes, I'll try to do it short. This work is, it's called Evaluation of Level of Development in Students' Design Models in Engineering Education. And it's mainly made by my PhD student, Simon, and who's the first author, and the rest of us are his supervisors in different aspects of his PhD work. So, yeah, and I have the possibility to present it here. So, yeah, as I mentioned, this is part of a PhD project. The title of the project is Interdisciplinary Information Exchange Between Actors in Design and Renovation Projects, and he has very much focus on during the project on the information management. How do we handle information about the project we are designing, looking into design rationale, design intent. How do we represent that in different models and documents and so on. So as a small part of this paper examines information content or level of development in some students' BIM models at an interdisciplinary workshop, the Digital Days, which I also mentioned earlier. And referring to our earlier discussions, BIM models here means Revit models. So it's narrowed down to that. Where the models from these students are created is during this event we call the Digital Days. This is a 3-day interdisciplinary workshop we make within 4 different education institutions in the North Jutland in Denmark. And we can have up to 10 different educations participating. So we have different craftsmen, carpenters, and so on. We have construction architects and other bachelor education from the university college. We have different engineering disciplines from Aalborg University participating. And they are put together in large teams, between 10 and 25 persons in each team, typically with these different disciplines. And they are given a task to basically design a building, take into account all aspects of designing a building within 3 days. And they didn't know each other before in these groups, so it's quite challenging. And we call it Digital Days, so they are going to use, we have focused on using digital tools for this, and they're giving the task to design this, and they must, after 3 days, they must hand in their BIM models of different aspects of this building, and they must hand in different kind of analysis, and they must give a presentation of their work. And then we have an assessment committee assessing, and we find a winner, and they get an award and so on in the end. So that is that should give some motivation to do a good work. So what we did here was we took these models from basically the last 3 years. We have done this, and you can see here we have over the years we have different number of participants, about 100 participants in 2019, almost 300 in 2021, and 180 in 2022. So this gives us different number of teams and different number of persons in the teams. This ends up that we have collected 36 Revit models from these years, and then we analyze them with respect to level of detail. And how we defined level of detail is we used a Danish definition. There's a group of companies in Denmark. They call their group Decon, and they have made this their own level of detail standard, where they have a level of reliability, level of geometry, and level of information. So we follow their standards to look at the content of the students' models here. And again, to be able to compare between different years and different groups where they had different projects, we decided to look into these 4 different components: the exterior walls, the first floor deck, windows on first floor, and a building roof. So we assumed these would be in all models. And the results, we found that the models actually had generally low level of detail compared to what we expected from what we knew the students had learned before, so what they should be able to do, and also related to the requirements we gave to the task here. For example, there was a requirement to make a classification of all building components, again related to a Danish specific classification system, and we also asked them to use the BIM models as a foundation for making different kind of analysis, for example, in energy analysis. So we would expect that then they would, for example, put U values on the windows and so on. So we had different properties we looked for. So basically, what is why we discussed what are the possible reasons for this relatively low level of detail the students provided in their models, and was it missing skills? And as I said, we don't think it should be missing skills, also because actually when we looked into the models, they were prepared to put in that classification code. So the students actually did something to be able to do it, but they didn't do it. It could be low motivation, but they could win the award, and they could, and we gave them requirements, you should put this, so why didn't they do it? Of course it could be they were busy because it's within 3 days and so. But also we saw at least some connection that if the project they were doing in this workshop had relation to their ordinary work in their semester, then they had higher motivation, then they could reuse it and that and so on. So maybe, and then they would have, you could say, more ownership of the model and have more their own interest in putting information into it. But yeah, basically we are discussing that in the paper, and we don't come up with any specific conclusion, but have these ideas. What could it be? But also this raises a discussion: how can we motivate students to actually make good quality work? And the model here to the right is not a BIM model, but we also worked with with some physical models during the workshop. That was all. I did it less than 10 minutes.
Excellent. You get the award of keeping time.
So,
Yes.